how are you doing? My name is Junction, and today I'm going to take you through a site inspection of beams. Hope you will learn a lot. So we are in this site. We have actually done the formwork. We're done with formwork fitting. Now we are doing beam steel reinforcement fixing before we do the slab and concreting. So please come with me as we learn about the rules to follow whenever you're doing inspection of reinforcement in concrete slabs and beams. So you can come with me. Yeah, so as you can see, these are beams. We are doing the steel fixing, and let's use this beam to learn a few things. For instance, we have this length that has just been bent, the length of the bar. This is called development length, and it is actually determined depending on the code of design that you are using. And it is normally instructed by the engineer on the size of the length to use. For instance, if I can measure this one, this is 100. That means the engineer detailed this to be 100 millimeters. Therefore, you need to follow development length whenever you are doing reinforcement in beams. Secondly, from observing our beams, you realize that there are two layers of reinforcement. At the bottom here, we have the first layer. The first layer has 3 bars. As you can see, those 3 bars are the first layer, and the second layer has 2 bars. Therefore, the second layer is not supposed to have development length, and actually you can make it a bit shorter than the bars with development length. Also, because the layers are 2, you need to insert a spacer in between them so that you keep the space in between to prevent cracking of your beams whenever you are doing concreting. As you can see here, this is a spacer, the one I have mentioned. It is separating the 2 layers of steel bars, and our spacer, the minimum diameter of the spacer is supposed to be the diameter of your bar, your main bar. Therefore, if this is a T20, then the spacer is supposed to be T20 or more than that. And also in this beam, as you're seeing, that whenever we are counting these bars, this is normally known as top 1 and this is top 2. You start counting the tops from the top, and when we get to the bottom, this is bottom 1 and this is bottom 2, just the same way we do when we reinforce a slab. And then these 2 bars are tied together using a binding wire, or you can weld it or use coupling, but use of binding wire is easy to fix on site. And as you can see, we are not yet done with this beam. These ones are called shear links or stirrups, and hope you can see the weakest areas of the stirrups, that is the joints, are alternately placed so that we prevent having more than 50% of them in one side. For instance, the weak area is here. The joint of this stirrup is here, as you can observe, and this one is here, and this one is here as you proceed. So though this is a mistake, you're not supposed to do this at 90 degrees. You're supposed to maintain an angle of 135 degrees of these your shear link weak areas, as I will show you later on in this post. So we can also look at this. This is a spacer. We have already talked about it. It is separating the 2 bars. This is a T25 bar, and the spacer's diameter must be a minimum of 25 millimeters of your bar. Therefore, you need spacers all through the length of your beam so that your beam, your bars are able to be clearly spaced. Also, we are done with that. This is a beam column junction. We have already talked about development length, and the second layer bars, and it's not a must that they have development length. Another thing to inspect is also the spacing of your stirrups. And as you can observe here, this is 150, almost there, center to center of your stirrups. Therefore, ensure that the minimum spacing of the stirrups is obtained, and the stirrup spacing is also required to reduce, or you space these shear links closely next to the support and in areas where you have overlapped your bars. Therefore, because this has been obeyed, it is almost 150 millimeters center to center. Therefore, that is sufficient, and this bar is close to the bar of the main column, so that we avoid shearing at this area. Another thing to ensure is also your bars are not congested in an area to prevent concrete from passing. For instance, when we will do concreting here, we will need concrete to pass through so that we achieve the minimum cover we designed for this beam, which was 25 millimeters. Therefore, we need to have enough space for the aggregates to pass. And whenever you're doing design, with this beam, we needed 20 millimeter aggregates for them to pass through this bar so that we get the cover. Because if you do not maintain the space, then there will be segregation of your materials whenever you're doing concreting, and you will not obtain enough cover. Therefore, we have tackled quite some good amount of things you need to look at whenever you're doing inspection of steel beams. So if we move to the second one, I talked about these shear links, and as you can observe, they have been bent at an angle towards the inside. That is what is required, though this angle has not reached the required, these bars have not reached the required angle, because we need 135 degrees to be bent inside. And we can just proceed. Hope you observe there. Yes, this one, the angle between this and this, yeah, these two, the angle is required to be 135 degrees and not 90 degrees at this junction. And also you need to overlap these your shear links whenever you're tying, so that you avoid having an area with more than 50% weak areas. So we can proceed. Continue coming with me. I want us to also learn something. You see, work is in progress, and this is actually almost 135 degrees. This is a beam that we have started tying, and as you can observe the shear links, look at our shear links. The weak areas are bent towards the inside at a certain angle, which is always suggested to be 135 degrees. Therefore, that has been done the correct way. Also, spacing, for instance, the spacing of these shear links was 200 millimeters. From here, you can observe also this beam has development length. The main bars have development length, which is cranked and tied to the main column whenever we are doing steel fixing. So this is a shear wall, yeah, and you see we have shear links inside the shear wall. It is always good practice that you insert your links through those beams going through your shear walls, and in columns you can avoid that because of maneuverability and ease of work. But in shear walls, it is always expedient that you have your beams having your stirrups depending on the spacing they were designed for. Now, welcome to this other beam. As you observe the shear links, of course, these ones have been bent at an angle of 90 degrees. and it is wrong. It's supposed to be 135, so this is a mistake, but the spacing was supposed to be 150. Let's check it out. It's more or less, yeah, so that is okay. And now we come to this junction. At this beam junction, there is something I would like you to note. You realize that this bar is below this one, and this is a T25 bar and this is a T20 bar. Therefore this beam is the one that is expected to be carrying this other beam here. Therefore you also need to inspect your beam junctions so that you ensure the main beam carries the secondary beam whenever it is reinforced. And even the top, because of hogging moments, then the topmost bar of your main beam ought to be at the topmost point, just the same way it is at the bottommost point. That is why your main beam is supposed to be having the first bottom and the first top from the top, and this secondary beam will have the second bar, and from the top it will also be the same case. Therefore that is all for now from this beam junction. You also need to look at your overlaps, and overlaps are yet to be done by the time we are doing this inspection, but there is a joint. You can see this is a joint. The bars are continuous to the other side and the other side, and this joint has been made right after the column. So you are also supposed to inspect your length of overlap, just the same way we inspected the length, development length. And hope you can see here, this is around 1250 millimeters, and whenever you use a formula of 50D, a T25 bar is required to have an overlap length of 1250. Therefore the length has been obeyed, but has the location of lapping been obeyed? You realize these will be the bottom bars of this beam, and they are being lapped next to a shear wall, which will act like a column in this case. Therefore we are not supposed to lap these bars here. We are supposed to lap these bars here L/4 distance from our columns, because they are bottom bars. And whenever we get to the center, like here, this is the region that we will be required to lap our top bars, because we experience maximum deflection at this stage. Therefore we cannot lap bottom bars at this stage. Therefore in a beam at a distance of L/2 you lap your top bars, but in close to walls and columns you lap your bottom bars next to the column at a distance of L/4. Therefore also whenever you inspect your beams, please ensure that you obey the overlap rule. One thing to note, even if we were doing beams today, hope you see these shear walls. The length of your main bars is more or less the same, and this is wrong. It's supposed we're not supposed to have a weak region. 50% of the reinforcement, all of them within the same region, and just come with it. Here they have tried to do alternate lapping, but they have not been able to achieve it because it is more or less within the same region. And we can just proceed. Here is what I was talking about. You see, this beam is supposed to end there, and it will be lapped at this section. But you see, the position of lapping is the same as the bottom position. Therefore this is wrong. They're supposed to lap these bottom bars close to columns or shear walls, and the top bars at the L/2 middle region because of maximum deflection at this stage. Therefore, these top bars are rightly lapped, but the bottom bars ought to be lapped next to the wall. Therefore, this one is supposed to be changed. And we also observe the rods. Please ensure that before you start any steel fixing, your formwork is okay. Therefore, whenever you are also inspecting formwork, inspect the width of your beams. For instance, here my width is supposed to be 200. Therefore, we have lost 10 millimeters from this beam, and we are supposed to do that from also down here. As you can see, we have lost around 10 millimeters in this beam. Yeah, but because also it is human beings who are working here, sometimes they get tired, and these are not machines. Precision is sometimes a problem. Therefore, ensure your formwork is okay, your angles are achieved, and please also check on whether your 90 degrees are observed here. And to do that, you can take panels, for instance this slab panel, and for instance when you have this slab panel, you can measure the dimensions of your diagonals. If they are equal, then that means that you have obeyed the 3-4-5 rule, and your room is either a perfect square or a perfect rectangle. Therefore, please also inspect that to ensure that you have joints of masonry or walls that are 90 degrees. And as we're finishing up, look at this column. The main bars have been lapped almost at the same region, which is not supposed to be the case. We are supposed to have at least a maximum of 50% of these bars lapped here, and then we have others lapped at some distance below. And also you need to look at the lapping distance for your columns. For instance, this is 1.5 meters, which is 1500 millimeters, and if you remove a slab of 150 millimeters, then that is 1350. Therefore, you have enough distance of overlapping, and the overlapping distance is okay. Also, the region of overlapping should be observed. You are not supposed to lap a column at a distance of L/4 from either from the slab or from the bottom of your beams. You are supposed to lap them at the middle part where the bending moments in your columns are close to zero, if not zero. Therefore, this is also wrongly done. And we have one here. When you observe this, you might think it's correctly done, but even if these ones have been lapped at a different distance than these ones, we are supposed to alternate them. This one is supposed to be high, this to be low, this to be high, this to be low, so that we don't have a region of weakness along our one area. For instance, these middle bars, which are T20 bars, are lapped at one area. Therefore, all this area will be weak, as opposed to lengthening the bars in an alternating way. Therefore, this has we might have achieved 50% here, but we are supposed to alternate them so that we don't have a uniform region of weakness. And also, when you look at this, it is close to L/4 from the bottom. Therefore, this position of lapping is wrong. We're supposed to lap towards the middle L/2 sections of the column. And this column also, you can see we have 20 bars longer, and then T25 bars longer and T20 bars shorter. And you can observe that this has been done in a way that is almost alternating. Therefore, we have almost 50% region of weakness within this area and within this area. Therefore, this one has been alternated. although where the lapping of these has been provided is not correct. It's supposed to be L/2 middle part of our columns. Therefore, in terms of alternating to avoid lapping all of them at the same region, this one has achieved it, but this bar is close to L/4 from the bottom. Therefore, it's supposed to be slightly longer for lapping. Also, whenever you have your reinforcement, you should not ensure that work flows easily and quickly, so that your bars do not rust. And if they rust, you need to scratch them with a wire brush to remove the rust before you do your concreting. For columns, we were not doing columns today. Those are just things I have observed as I'm doing inspection. And you can see, if you have a junction of two beams, the main beam carries the other beam. Therefore, also observe that, as we have said, from the other sides. And hope you have observed something. The weak areas of your links are always at the top. We have not placed all these weak regions at the bottom. Ensure that they are supposed to be at the top, because if they are at the bottom, then they will create a weak region at the bottom, and due to deflection, that might affect your beams. And in case of maybe earthquakes and seismic issues, then your beams might easily fail. Therefore, please have your weak regions of your shear links in beams always facing the top side. Therefore, thank you very much. I hope you have learned a lot, and please ensure that you keep these whenever you are going to site. Ensure that work is done to standard, so that we don't do poor quality work. Thank you. My name is Engineer Msongo, and please subscribe to this channel. We will teach you and guide you through design, inspection, and all that matters civil engineering. May the good Lord bless and keep you. Thanks.